Hi, today is derivatives day 2. Particular, we are focusing on the product and quotient rule. All right, so this is another very big and important part of the differentiation rules. And from the name, it's regarding products and quotients. So multiplication and division. So let's talk about the key idea. When we want to find the derivative of the product or quotient of two or more functions, we must follow a set of rules. So pretty straightforward. So when we are trying to find the product or the multiplication or the differentiation, in other words, the division of two functions or potentially more functions, but it's usually two functions, there's a set of rules we have to follow. So it's similar to the sum and difference rules for two functions, except this is multiplication and division, and it is done differently. Right, so let's talk about what not to do, because a lot of people in my class did this and they ended up getting the wrong answer. So this is what you cannot do. So they are not similar to the sum and difference rules in that you cannot, again, you cannot, let me use the red one to indicate that because I cannot indicate this enough. You cannot do this, right? You cannot just, I guess, open the brackets. You can't just do, oh, I'm finding the derivative of f of x times the derivative of g of x. You can't do that, right? This is not allowed. So you can't just open the brackets. That's not how it works, and that's not allowed. And for the division or for the quotient, it's the same thing. You cannot do that. So you cannot do this. D of x of f of x divided by. This is not allowed as well. You cannot just it's not similar to sum and difference. You can't just expand the bracket and just take the derivative of everything. That does not work in these conditions. So this is not allowed. So now let's look at what you should do, right? So for the product rule, this is the formula right here. All right. So what you need to do is actually do this. And it might be strange at first, but you'll get used to it. Again, the proof is on the website. I'm not going to explain it because that's way more detailed and that's a bit on an advanced level. But the proof is again on the website, on my website, link in the description if you guys want to check that out. But going back to this, so to find the product rule for two different functions that are being multiplied or together, let's start off with the product rule. What you need to do is, instead of just opening the bracket, you just need to memorize this formula. First, you need to take the derivative of one of them and then multiply it by just the original function of the other, and then add it, add it to the regular function of the first one that you took the derivative of, and then multiply that with the derivative of the one that you first took the original function of. So I know that sounds very complicated, but I'm just trying to use words to describe it. But I'll also show examples, and hopefully it'll be clearer. So essentially, when you want to take the derivative of this guy, all you can do, again, I'm just using two notations here. That's why there's two. It's or. They both same thing. So let's look at the Lagrange notation because people sometimes find it easier. Basically, first you take the derivative of one of them, and in this case, I'm going to take the derivative of f of x. By the way, this dot means multiplication. And you're going to multiply it with just the original function, not the derivative, pay attention, just the original function of g of x. Then you are going to add it to now the original function of f of x, so not the derivative, not like the first one here, to so the original function, and then you're going to multiply that to the derivative of g of x, which you originally just took the original function of. All right. Again, if it sounds confusing, I'm sorry. I'm just trying to put it into words, but hopefully, the formula itself should make sense. Basically, you're taking the derivative of the first one, multiplying it with the normal function of the second, then adding that to the original function of the first one, and then taking the derivative of the second. So you're just switching. You're switching rules. So let's move on. And a note for this is that the order for which function you differentiate first for product rule does not matter. All right. So to make more sense of that, basically, it doesn't matter if I first take the derivative of f of x and then multiply it to g of x, or if I first take the derivative of g of x or multiply it to f of x. That does not matter. And the reason I'm saying this is that because it actually does matter for the quotient rule. So I'm just letting you know for the product rule for now, it does not matter. So it's right. It doesn't matter which one you differentiate first. You just need to make sure that after the addition sign, you switch up the roles and then you differentiate the one that you first took originally, and you take the original function and multiply to that from the one that you differentiated originally, right? So I know again might sound confusing. I'm sorry, but just trying my best to explain it. And so now let's do an example so you guys can guess what I'm on about, try to figure out what I'm on about. So find f of x, f prime of x for the function in brackets 3x squared plus 2, in brackets 2x squared plus 1, right? So let's just call this one f of x, and this is g of x, all right? So let me just write out my original formula, all right? So if you guys remember, the derivative of, oops, just trying to find it here. All right, sorry about that. Just need to add it. All right, so the derivative dy over dx of f of x times g of x. I'm just going to write out the formula so you guys can just remember. So again, we do not open the brackets, we do not expand the bracket. Instead, what we do is we do this. First, I'm going to take the derivative of f of x, multiply 2g of x, and then addition sign. There's always an addition sign, and then I'm going to reverse roles. So now, oops, there we go. Sorry about that. So now I'm going to reverse roles, and now I'm just going to multiply the original function of f of x with the derivative dy over dx of g of x. And I just remembered I should not put a y here because I already have a function in front of it. So d over d of x of g of x, right? So I'm going to do that. That's my function. Again, look at how I switch roles, reverse roles, right? So that's the function I'm going to be following, and that's pretty much it. Now I just need to plug everything in, all right? So let's go to the answer. And the original, let me just write down quickly the original function, or the two functions, 3x squared plus 2, 3x squared plus 2, 2x squared minus 1, 2x squared minus 1, all right? There we go. So again, following that rule, here we go, all right? The derivative of the function is, so this is f of x, right? So first I'm going to differentiate this. If I differentiate this, and remember my differentiation rules, it should give me 6x plus 0, so it's just 6x, multiplied by g of x, which stays the same because it's the original one. We don't take the derivative of that, and then add it to, there's not a lot of room here, so I'm just going to, sorry, but I'm going to have to make it on the next line. So for this time we do the opposite. So this time we take the derivative of g of x, which should be 4x, again because this 2 comes down, multiplies with the multiple constant, which is also a 2, to get 4, and then 2 minus 1 for the exponents is 1, which is just x, and then that negative 1, that is just a constant, so it's 0. The derivative of that is just a 0, and then that multiplies with the original function of f of x, all right? 3x plus 2. Perfect. All right, so let me write that. Let me just make it a bit neater. It's equal to 6x, 2x squared minus 1 plus 4x, 3x squared plus 2. All right, so there we go. And now it's very basic from here, very downhill. All we're going to do now is we're just going to open the brackets, and we're just going to multiply stuff together and simplify it. So 6x squared goes into here, multiplies into 2x squared and negative 1. So 6x times 2x squared is obviously 12x cubed minus 6x, right, plus, and please remember to keep these brackets until you've opened up everything. 4x times 3x squared is 12x cubed plus 8x. All right, now that we have both sides, let us just Put everything together now. 12x cubed minus 6x plus 12x cubed. 12 plus x cubed. Oops, let me just write that better. 12x cubed plus 8x. All right, so now these two add up, right? So 12x cubed plus 12x cubed is 24x cubed, and oops, negative 6x, and then negative 6x plus positive 8x is just positive 2x, right? And that is it. That is the derivative of the product of these two functions, all right? So basically, if these two functions were to be multiplied together, their general derivative, again, I made a video about general derivatives, would be 24x cubed plus 2x, and that is all you need to do. Just remember the product formula, and then just literally plug everything in, and it should be pretty straightforward from there, all right? So now let's look at the quotient rule. Quotient is just another way of saying division. So it's what if you're dividing two functions this time instead of multiplying, and you want to figure out the derivative, right? So note, in the earlier one, I just said order doesn't matter. It doesn't matter which one you differentiate first. For quotient rule, you do need to pay attention because order does matter. And if you get the wrong order, you'll consequently get the wrong answer as well. So the formula for the quotient rule is a bit more complicated. It's really not that hard. It might appear a bit big, but it's pretty easy once you start to do it. So the formula is right here. So the top part right there. Actually, let me just use red or red. There we go. So the top part up here is actually very similar to the product rule, the formula for the product rule, except this time what you might notice is that there's a negative sign instead of an addition sign, and the order this time does matter. And the order, please pay attention. The order is the numerator will always be differentiated first, and the denominator will always be differentiated second, so after the subtraction sign. And the other thing you need to pay attention to is obviously this denominator part for the formula of the quotient rule. Basically, the denominator is taken and then squared to become the denominator for the quotient rule for finding the derivative. So those are the main differences and similarities. Pretty much the top part stays the same, except instead of an addition sign, now there's a subtraction sign, and the order actually does matter, in which the denominator needs to be differentiated first. And then obviously we have this new addition, like I said, the denominator part to it, which is just the denominator of the two functions squared, right? So let's look at an example for this. So find the derivative, or in other words, find f prime of x for f of x is equal to x plus 1 divided by x squared plus 1, right? So let's just call, I think to make this, I guess, better to understand, let me just call this y. Let me just call this y, all right? And let me call the top part f of x, because I'm trying to make it two functions for you guys so that it's more relatable and it's easier. And let me call the bottom part g of x, all right? Well, I just saw, and we just saw together, that the derivative of dx, let me just go back, the derivative, and again, I should probably erase that, of f of x over g of x is again very similar to, for the top part at least, very similar to the product rule. However, there's a subtraction sign instead of an addition sign, and the order does matter. So f of x multiplied by, no room, hate it when that happens. Let me try to make this smaller. All right, f of x multiplied g prime of x, right? Let me see if I can close the bracket. Yes, I can. All right, and then the denominator, of course, we cannot forget that, g of x all squared. All right, so that's the formula. And now let me show you the work Let me just go back and get the original equation. X plus 1 all over x squared. Is that also plus 1? Yes, it is plus 1. All right. All right, so we just saw the formula. So now let's just apply it, all right? So f prime of x, I'm just going to call this f of x or y. F prime of x is equal to, so let's start off with the top part, all right? So x plus 1 is, we're just going to call that f of x, and then g of x is going to be the bottom. So first I would need to take the derivative of x plus 1. That's actually going to be very easy because it's only 1. Please remember that that x is to the power of 1. That 1 comes down. 1 minus 1 is easily 0. X to the power of 0 is just 1, so 1 times 1 is only 1. All right, and then I'm going to multiply that with the original function for g of x, which is just x squared plus 1. Remember, subtraction sign, not addition. And now I'm going to take the original function of f of x, x plus 1, and now multiply it with the derived version of g of x, which should just give me 2x. And the reason for that, again, the exponent comes down, becomes a constant multiple, so the 2 comes down, and then we have to subtract 1 for the exponent's place. 2 minus 1 is just 1. X to the power 1 is just x, so 2 times x is just x. And that 1 is a constant. The plus 1 is a constant number, so the derivative of that is just 0. And then please do not forget, some people do forget for quotient, the bottom part. There's still a bottom part. The bottom part is x squared plus 1 because that's g of x, and then all squared. All right, and now let's just continue to simplify this. So for the top part, I'm going to start multiplying. All right, so for the first side, 1 times x squared plus 1 is literally just x squared plus 1. And then the subtraction sign, I'm going to put this in brackets. And I'll show you why it's important to put these in brackets until the very end. Now let me expand into this. All right, so 2x times x is 2x squared. 2x times 1 is just 2x, all right? And then for here, what I can do is, this is the same thing as x squared plus 1 squared. I'm just going to keep it like that for now. So for the top part, it's very important, especially when you have a negative sign, to keep these in brackets. And the reason for this, okay, I think I might have made that look too much like an equation sign. It's very important to keep the brackets because when there's a negative sign, it does not just apply to the 2x. It actually applies to the whole thing. So everything has to be subtraction. So it actually has to be x squared plus 1 minus 2x squared minus 2x, right? All over x squared plus 1 all squared, all right? So your f prime of x is equal to the negative 2x squared being added to the x squared. So this with this just gets you a negative x squared, and the negative 2x does not change, so that just stays there, and then plus 1, all right? And then all over x squared plus 1 all squared, right? Now I just want to see if there is any other way to simplify this, because that's another important thing. You need to try and simplify your answer as much as possible. Negative x squared minus 2x plus 1 all over, oops, went forward, should have gone backwards, x squared plus 1. That is the same thing, I believe, as saying x squared plus 1, and x squared plus 1. All right, so I don't think there appears to be anything simpler. I'm just going to try and just do some quick math here just to confirm. Plus 2x minus 1. Does not appear there is anything more to that. So it looks good, and I think that is it. Right. So anyway, that was today's video about the product rule and quotient rule, and basically, I just wanted to make sure that you guys know about these rules because they're very important. Like I said, product rule and quotient rule, you're going to find them throughout, and you're going to find them a lot in the differentiation unit. Please remember, they are not like the sum and difference. You cannot just apply this method of expanding the bracket or opening the bracket. It doesn't work. There's actually a set of formulas that you need to memorize. And again, practice does make perfect. And so I just confirmed, while I just told you all this, that there is no simpler, this cannot be simplified any further. So this is the final answer. And oops, and it's totally alright if you keep it like this, right? So even though it might seem big or it might seem unsimplified, this is actually this is totally okay as a final answer, at least for now at this stage. So yeah, that's it. Please remember, if this might seem confusing at first, that's totally okay. I felt confused at first as well. When you do more practice problems, when you get to know the topic better, and you get to work more around these topics, it'll get easier and easier for you, and it'll get more comfortable for you as well. With that said, if you guys need extra notes, extra explanations, please head over to my website. Check the link in the description. It's 100% free. I have extra notes, extra practice problems with varying levels of difficulty, and I also have solutions to all those problems in full detail with full work shown, so you guys can know where I got my answers from. And anyway, that's it for today's video. Thank you guys so much for watching, and stay tuned. I have more videos coming up on the derivatives unit. Thank you so much.